Okay, so for the last part of Chapter 7, we're looking at connected particles. And a connected particle is any kind of system where you have more than one thing where we're going to have forces acting on those things. And most of the common kind of scenario questions you'll get for this are things like pulleys, strings, but the main thing is, again, is multiple particles that are connected together. So they all work within the one system, but we treat kind of each one individually when we're going through and working them out. Okay, so our first scenario is we've got two particles, P and Q, of masses 5 kilos and 10 kilos, and they're connected by a light, inextensible string. The string passes over a small pulley which is connected at the fixed at the top of a rough inclined plane. So I'm going to draw the plane. There we go. It's rough, it's inclined. We have a pulley at the top, so I'm just going to draw a circle for the pulley, and then there's the vertical line coming down the plane. Okay, we've got particle P. I'm going to use a red dot for P. Okay, so this is particle P. P is on the plane. And then we have Q, it's green, and Q hangs on the edge of the plane attached to the vertical string. Okay, so there's P and there's Q. And here's the string, which is coming up over the pulley and connecting those two there. Okay. P has a mass of 5 kilograms, so P is exerting a 5G force downwards. Q is 10 kilograms, so that's exerting a 10G force downwards. The plane is inclined at angle alpha, okay, where again tan alpha equals 0.75, so tan alpha is therefore 3/4, and we have our 5, 3, 4 triangle that we can use to work out anything that we need to know. Okay. The coefficient of friction between P and the plane is 0.2. So if you imagine if this was released, that 10G force, that's going to pull downwards, which is going to pull the 5G up. So our friction is acting down the plane, 0.2 R. Okay, we also have, it was 0.2, wasn't it? Yep, 0.2. We also have R, which is perpendicular to the plane. And I believe, we also have tension. So we also have T in the string, and we have tension in the string acting upwards as well, and they are equal because it's the same string. From here, the last thing that we have to do is, we have to talk about the acceleration, okay? Because the question says find the acceleration of the system. So if we imagine this system is released from rest, so which it says here, the system is released from rest, again, this 10G force, that's going to pull downwards. So at Q, we've got acceleration moving in this direction, okay? And this, and our acceleration of P, that's in line with the plane. So our acceleration for P is moving in that direction there. Okay, so now if I'm wanting to find the acceleration of the system, again, we've got F equals ma. So we know the mass for both, we need to know the forces, so we're going to resolve. So if I take P to begin with, so taking P, okay, if we resolve P, I'm going to resolve out of the plane, okay, so we're resolving out of the plane, so we're looking at all the kind of vertical components here. Okay, we've got R minus, no, go away, minus 5G, again cos theta, because we're looking at that angle there, so cos alpha not theta, cos alpha equals to 0, okay, or here you can write mass times acceleration 0, but your acceleration for the going out of the plane is a net 0 force, okay, so that means that R equals to 5G times by, now cos alpha would be adjacent over hypotenuse, so 4 over 5, so times 4 over 5, cancel that through, so R equals to 4G. Right? If we now resolve in line with the plane, and again, these kind of questions, if you're not sure how to start, just start by resolving the forces, and once you do that, then that's going to make your life a lot easier. You'll have, you should have plenty to talk about from there. So just start somewhere, anywhere, it doesn't really matter. Okay, if we resolve in line with the plane, we've got tension, so T, which is in line with the plane. We also have 0.2r, so negative 0.2r, because that's acting opposite to our tension. We also have the 5g sine force going downwards as well, so that's in the same direction as friction. So minus 5g sine alpha, okay? And in this case, it's equal to 5 times by your acceleration, okay? So 5a, because our mass is 5, and our acceleration is what we're trying to find, okay? So from here, we can work a little bit of this out. So we can say t times 0.2 times 4 is 0.8. So we can say minus 0.8 g. Okay, so that's 0.2 times by 4g minus 5g sine alpha equals, oh, sorry, I should do the sine alpha as well. Minus 5g sine alpha is 3 over 5, so times 3 over 5 equals to 5a. Okay, again, we can cancel through by the 5, so we've got t minus 0.8g minus 3g equals to 5a. So t equals to 5a plus 3.8g altogether. Okay, so now we can look at looking at the Q component of the system. So now if we consider Q, Q has only vertical components, so there's no horizontal, there's no plane, it's just working purely in the vertical direction. So if we consider Q, now we want to resolve in the direction of acceleration, okay, because otherwise you'd be looking at negative a, it gets confusing. So try and always resolve in the direction that your acceleration is going. So from here, we would then say, if we look in the direction of acceleration, 10g minus t equals mass times acceleration. So 10g minus t equals to 10 times a. Therefore, t, positive t. Okay, so therefore, positive t equals to 10a. So negative 10a, because positive t, so negative 10a plus 10g. Okay, so there from here, we can go through, and because we have t and t is equal on both sides of our system, we can equate these variables. So we've got negative 10a plus 10g equals to 5a plus 3.8g. So therefore, negative 15a is equal to I think that's negative 6.2 g. Yep, perfect. So therefore a equals 6.2 g over 15. So therefore the acceleration will be okay, 4.05 meters per second squared, and rounded to what, I think in the question we've got 2 sig figs, so rounded to 2 sig figs, 4.1 meters per second squared. Okay, there we go. Lovely. So that's part A for that question. I'm just going to pause this and rub it out, and I'll come back for B. All right, so to finish off, we are asked to find the tension in the string. So I'm going to go back. So I've written there part A, 4.1 meters per second. B, tension. This is the tension that we found with respect to Q. So negative 10A plus 10G. So now if I sub in A, I get negative 10 times by 4.1 plus 10 times 9.8. And overall, that gives me a tension of 57 newtons. Okay, and that's the end of the question there. All right, I'll make one more video with the second example from this, and then you are 100% done for chapter 7. Excellent.